We are on lesson 7.1, the guided practice, which is on page 176. It's really important that you try your best on these problems and only resume the video when you're ready to check your answers. So go ahead and hit pause, try 1 and 2, and then resume when you're ready to check. Okay, number 1, the ratio of oxygen atoms to sulfur atoms in sulfur dioxide is always the same. The table shows the different number of atoms in different quantities of sulfur dioxide. Complete the table. So this one looks a little bit tricky unless you start by simplifying it. And you don't even have to simplify it all the way down to its unit rate, but just start by simplifying it. And here's what I mean by that. What I'm going to do here is I'm going to add a column, and I recommend you do the same thing. And I want you to think to yourself, well, 6 doesn't go into 9. That's not going to. 6 can't help me get to 9. 6 doesn't go into 21. That doesn't help. But 3 would. So very simply, all I need to do, just watch what I can do here. This becomes quite simple. If I simply divide both 6 and 12 by 2, what would I get? I'd get 3, and I would get 6. Now, how is that helpful? Well, later I can do 3 times 3 is 9. And separately, I can do 3 times 7 is 21. And separately, I can do 6 times 9 is 54. So that can help you get all the missing numbers. So I'm going to clear. I'm going to start, if you didn't quite understand what I did there, I'm going to clear. I'm going to start from scratch. I'm going to help you find all these missing terms. Okay? First thing I'm going to do is simplify 6 and 12. Simply going to divide those by 2. I'm going to go ahead and make this just a tiny bit neater. I'm going to go ahead and color this, and then I'm going to rewrite it in blue. I'm going to simplify 6 and 12 simply by dividing by 2, and I would get 3 and 6. And then what I notice is that this missing term right here is 3 times greater than this. 3 times 3 is 9, so 6 times 3 is 18. So this term has to be 18. And I can go ahead and erase this because I'm not going to use that anymore. And I'm going to do this is the way I get the next one. How would I get from 3 to 21? I would multiply by 7. So you have to multiply the oxygen also by 7, and I would get 42. And if you're thinking to yourself, well, Mr. Smith, I noticed something else here. I noticed that the bottom column is always twice, the bottom row is always twice the top row. And that's true. All of the oxygen values are twice as much as all of the sulfur atoms. So that could help you get the top row as well. That would make this term 27 right here. Watch how this you can prove this 2 different ways. 6 times 9 is 54. So 3 times 9 is 27. You didn't have to prove it that way, but you could. So question 2 is a build of question 1. It says, use the table in exercise 1 to graph the relationship between sulfur atoms and oxygen atoms. It's really important to recognize that they set it up as the first row is the x-axis and the second row is the y-axis. So simply put here, we're going to graph 6, 12 first. That means over 6 up 12. And then I'm going to graph 9, that's over 9, up 18. That's going to be right here. And then over 21, up 42. And over 27, up 54. And if you used a straight edge, you should notice that is a straight line. The reason why it's a straight line is because it says in the directions that the ratio over here, the ratio is always the same. That makes it a straight line. Well, I guess I skipped part of number 1. It says, what are the equivalent ratios shown in the table? They're all equivalent to each other. And how do you write this? This is a little bit confusing to explain, but I'll do my best. The equivalent ratios shown in the table, if you were to write them as the y over the x, which is what we did previously on problems like this, it would be 12 over 6, and that's going to be equal to, well, they're all equal. 18 over 9, and that's going to be equal to 42 over 21, and that's going to be equal to 54 over 27. And the reason why they're all equal to each other is because if you simplified all those, they'd all simplify to be the same thing. And we said earlier, basically all the y values, the second terms, are double the x values. So if you simplify any one of those, it'd be 2 over 1. All right, so as long as you've got 1 and 2 done, we can move on to 3 and 4. Once you pause the video, try 3 and 4, and then resume the video when you're ready to check your answers. Number 3 reads, stickers are made with the same ratio of width to length. A sticker 2 inches wide has a length of 4 inches. Complete the table. So this information at the beginning right here says 2 inches wide and a length of 4, which means that your first column is 2 over 4. And a lot of kids would then just use that information to say, well, does that mean that the top term has to be half of the bottom term? And that's true. Very simply put, if the ratio remain the same, then this one's going to be 4 over 8, and this one's going to be 7 over 14, and this one's going to be 8 over 16. Those are all correct. It says, what are the equivalent rates shown in the table? Once again, and it doesn't really matter, but once again, if you flip these and did the y's to the x's, you would say that the length is going to be 4 to 2, and that would be equal to 8 to 4, and that would be equal to 14 to 7, and that would be equal to 16 to 8, and they'd all be equal to 2 over 1. In other words, the length is 2 times the width. Question 4 says, graph the relationship between the width and the length. And notice that the width is the x value and the length is the y value. So you'd go over 2 and up 4. And then the next pair is 4 and 8, so you'd go over 4 and up 8. And the next pair is over 7 up 14. And the next pair is over 8 up 16. And you would graph that, and that would be a straight line. That one, interestingly enough, was quite a bit easier than numbers 1 and 2. So let's go ahead and check out number 5. Pause the video, try number 5. Resume when you're ready to check your answers. Number 5 says, 5 boxes of candles contains a total of 60 candles. It's pretty important. 5 boxes of candles is 60 candles. It's pretty important that you notice that, because right now the table doesn't look like it has enough information. It says each box holds the same number of candles. Complete the table and graph the relationship. So this 60 right here goes with 5. So it's going to be 5 and 60. And a lot of kids would look at this and say, well, you can't get from 5 to 8. So this is where it would come in super handy to simplify. You wouldn't have to do it this way, but you totally could. Find the unit rate. If 5 boxes contain 60 candles, how much does 1 box cost? You can simply do that by doing 60 divided by 5. And you probably have that memorized, or you can use your multiplication chart. 5 goes into 60 12 times. So that means that 1 box is 12 candles. Now that information, that unit rate right there, can help you get all the rest of the numbers. If 1 box contains 12 candles, then 8 boxes would be 8 times 12. 8 times 12 is 96. And you may not notice this, but I do. 12 goes on 120 10 times. So what does that mean? It means 10 boxes. So now we've got all that filled out, and then we're supposed to graph. And you only have to graph the 3 given to you. You don't have to graph the 1 and 12. You could, but you don't have to. So the first one's going to be over 5 up 60, and that's going to be right here. Sometimes they make these graphs really hard to read. Over 8 up 96, and over 10 up 120. And as we've had up to now, all straight lines. Okay, we are going to go ahead and skip number 6 and move on to the independent practice.